Can we mimic human teaching into artificial intelligence? Can we mimic the qualities of human teaching into learning technology? What is the role of cognitive sciences and learning technology when it comes to build, design, and implement learning environments which are not only enriched by pen and paper, but also by virtual reality, augmented reality, or artificial intelligence, even ChatGPT in this context? In our today's webinar, we are going to address these and other questions together with our experts. Good evening, dear students, dear parents, esteemed colleagues and guests. On behalf of the Department of Cognitive Sciences and Psychology, it's my pleasure to welcome you to our webinar series, Bridging Cognition and Technology, under our upcoming master's program of Cognitive Sciences, Learning and Technology. Today's session is titled as Future of Teaching, Bridging Cognition and Technology with Intelligent Teaching Systems. We are truly honored to have participants joining us, spanning from different academic backgrounds, and of course our panel members. This webinar represents a diverse perspective on innovative practices and research, which we aim to offer as well our students under our master's program. And as our slogan says, design learning, empower minds, and prepare for a resilient future. It is my honor to introduce our keynote speakers today. Allow me to start with Dr. Sidney Strauss. Dr. Sidney Strauss is Professor Emeritus of Education and Psychology at the Tel Aviv University and former Chief Scientist of the Israel Ministry of Education. And at the Amrita University, Amrita Vishwa Vidyapeetham, he is currently the Director of Research in one of our research centers, AMMACHI Labs. A warm welcome, Dr. Sid. It is our honor and pleasure to have you here.
Thank you.
Our second panel member is our esteemed Dean of the School of Artificial Intelligence, Dr. Kamal Bijlani. And yeah, there is a lot to say about Dr. Kamal, but just to introduce you a glimpse of his background. Professor Kamal has over 25 years of experience in practically implementing AI in healthcare and digital technologies in e-learning products and projects worldwide. He holds 3 US patents and has over 55 Scopus Index publications related to AI, digital technologies, mobile apps, AI, image recognition, and pedagogy. Dr. Kamal led the national AFU video conferencing software project, which was installed at 12,000 colleges with a funding of 40 plus course with the Ministry of Education, IIT Bombay and IIT Madras. He has major projects, but just to give an idea of his expertise and background, he works in an AI in healthcare, a pilot mobile app, and deep learning model program in medical specialties, an AI-based tutor system with piloting a project tested with Omnex and Amrita, ample e-learning LMS software used by Skill Ministry for lakhs of students over several years, an AFU software developed at 12,000, developed and deployed at 12,000 colleges, as I said before, and I could go on, and there are a lot of awards as well. So Dr. Kamal is award holder for the Global Leader in Internet Innovations. He was given by Cisco, and one other award is the Award for Excellence in Technology given by FICCI at Niti Aayog Vice Chair from Dr. Aviv in 2016. So Dr. Kamalji, it is our pleasure and honor to welcome you here. Thank you so much that you have taken the time to enrich this panel.
It's an honor to be here. Thank you. Thank you.
Last but not least, our dear alumni, former and again colleague, Dr. Unnikrishnan. Dr. Unnikrishnan has over 10 years of experience as an R&D software engineer at AMMACHI Labs, where he specialized in developing skill training simulators and serious games for education. He earned his PhD from Aarhus University in Denmark where his research focus was on enhancing VR-based skill training through haptic feedback, stress detection using biosensors and adaptive learning techniques. Currently, Dr. Unnikrishnan works as a consultant, AI consultant, applying his expertise in XR and generative AI applications. A warm welcome, Dr. Uni. It's wonderful to have you here.
Happy to be here.
And so this is also the invitation to all participants to take the chance and ask questions and be active in the chat box if you wish, so that we can address our experts with your questions and allow them to answer them. Okay, so thank you again for joining. And Dr. Sid, shall I share your slides, or may I start with my interview questions? Okay, wonderful. Then let me do that. I'm sharing Dr. Sidney's presentation. I hope the slides are visible.
Yeah.
Okay.
Okay. So thank you very much.
Over to you.
Okay. Thank you. It is an honor to be here. Thank you for inviting me, Dr. Nandita. And I think most people who are listening in think that they know what teaching is. We've all been taught. We're all taught all the time, actually. And one of the things I'll be talking about is opening up the idea of what teaching is to include teaching, which does not necessarily take place in schools, in formal educational systems. I'm getting ahead of the story. So here we go. Nandita, can you show the next slide, please? Okay, so I'll be talking about human cognition and teaching. If it's possible to have negative knowledge about something, then I have negative knowledge about information technology. But I have some knowledge about human beings, and in the case of teaching, how humans teach and what's required for it. So I'll talk a little bit about the cognitive side of teaching. And you see on this slide some of the areas in which cognition impinges on, or areas of cognition and research in cognition impinge on teaching. So one on the upper left side is cognitive archaeology. There are people who are archaeologists, and I'll speak a tiny bit about that, who look at archaeological sites, and then they speculate whether or not teaching occurred. Those who are interested in the teaching part, whether or not teaching occurred in those places. I'll show you a bit about something about a place that is from 400,000 years ago in Israel, and half an hour car drive from where I live. And then there's the brain sciences. The brain sciences deal with what's called brain-to-brain coupling. How is it that human beings, one person's brain, influences another person's brain? In the case of teaching, you have a teacher, and the teacher's brain is teaching the learner's brain. Well, what happens in those moments, and how can you capture that with the technologies that we have available? The next group, or the next area, is ontogenesis. Ontogenesis means the development of individuals. And in our case, what I'll be talking about is the ontogenesis of human beings. And how is it that teaching develops the ability to teach and the ability to understand teaching, how that develops over time. And then we have cultural evolution. And cultural evolution, it deals with how is it that how is it that cultures change, and what is the role of teaching in cultural changes? I'll talk a little bit about that. Then there's cultural anthropology. Is teaching universal? So my guess is that some people in the crowd, in the audience, would think, of course, how could it not be? Could there be a culture without teaching? Well, there are some people who claim that there are some societies, small-scale societies, in which teaching does not take place. Personally, I don't believe that for a minute, but being an academic, I have to present two sides, at least two sides of an issue. And the last one is non-human teaching. Other animals that are not humans, does teaching take place there? And I'll ask you now, do you think that teaching takes place among all non-human animals? Or do you think it takes place among none, or some, whatever the sum could be? Well, I guess there's a big range between none and all. But it turns out that by a certain definition of teaching, which is inclusive for non-human animals, the number when the definition first came out for non-human teaching, it was found that there were about four, F-O-U-R, four animals that taught. And then you can ask, how does what they know how to do get passed down? I don't have time to talk about it, but it's something worth thinking about for sure. Okay, and Dr. Nandita, the next slide, please. Okay, I'll talk a little bit now about ontogenesis. I mentioned that earlier, and that is individual development, in our case, humans. And there are some strands of significance for teaching. There's the cognitive strand that develops. There's emotional development related to teaching, motivational development, and interpersonal development. Each of these developments impinge on teaching. And because I don't have much time to speak, I won't be able to go into any of them in any detail. I'll spend a little time on the cognitive development part, and it'll only be just a little bit. Okay, the next slide, please. So, what's involved in teaching? And most scientists of the groups that I just mentioned, that they think that teaching is the transfer of knowledge from an informed person, a teacher, to a less informed person, a learner. What am I doing now? I'm teaching. I know more about this, likely, than many of the people who are listening in, the learners. I hope I do. In any event, it's often seen as the transfer of knowledge, teaching being the transfer of knowledge. The next slide, please. Well, I'm going to add another component into teaching, human teaching, and that is, in addition to passing on information from the teacher to the learner, the teacher is likely to have an understanding of what learning is. And that's implicated in teaching. And why would that be the case? Because the purpose of teaching is to cause learning in others. So your understanding of learning is going to influence the ways that you teach. So understanding of learning on the part of the teacher is a component that is usually not spoken about in the professional literature. And next slide, please. Well, the way I talked about it, it looks like information goes from the teacher to the learner. There's a source and there's a recipient, but it's really a back and forth between them. The teacher teaches and passes on information. The learner asks questions, understands, doesn't understand. As a consequence, the teacher teaches differently, changes the teaching based on the teacher's interpretation of what the knowledge state is of the learner. Okay, next one, please. Slide. So before, the next one, please. Before you teach, you're already doing what's called state setting, or before you transfer information. You want to make sure, Dr. Nandita, could you press on that? I think what happens is, yeah, thank you. There's mutual readings between the teacher and the learner. The teacher picks up on the emotional state of the learner, also the motivational state and the knowledge state. So if you have a student and the student says, oh no, here we go again, math, I'm really not good in math. I'm not going to do well. By the way, there are a lot of people in math who I know who say, oh no, literature, I'm not good at literature. I'm not going to do well in this course. Your emotions come in and they influence your learning and they influence your motivation. Some people are spurred on if they don't know something and they're curious to learn about it. And some people, when they don't know, become upset and nervous. Okay, part of the knowledge aspect is that there's a knowledge gap. There's a knowledge gap between the teacher and the learner. So the teacher detects a knowledge gap and does things by all kinds of actions to try to reduce it. So how do you do this mutual reading of emotions, motivation, and knowledge? There's eye contact, body language, facial expressions. So while you're teaching, you're not just passing on and transferring information. Much is going on in the connection between the teacher and the learner. Okay, the next one, please. I'm going to make a claim. I'll go through it quickly. My claim is that teaching is a natural human ability. Dr. Nandita, could you move to the next slide, please? And I'm going to show you three sources of evidence for this claim. One is, the next slide, please. One is that children teach Another one is that there's teaching among our ancient ancestors. And another source of evidence for teaching being a natural human ability is that modern hunter-gatherers teach. So that's what I'm setting out to do right now. Okay, the next slide, please. So here's the first part. Children teach. If you give a moment's thought as to what happens in teaching, what's involved in teaching, you immediately recognize that it's remarkably complex. It is one of the most amazing inventions of nature, capital N. It is very, very complex. The next, please. Now, here's something some of you might have young children or have seen young children. It is rare, I think, that young children are taught how to teach. Who teaches a 3-year-old how to teach? It's rare. They are taught, but they're not taught how to teach. And nevertheless, they're able to teach. So think about this. Teaching is remarkably complex, and without being taught how to teach, toddlers age 3, about 1,000 days old, that's nothing. Half the time in their lives, they're sleeping, 500 days. And they can figure out what teaching is without having been taught how to teach. Next slide, please. So I've done some research with a colleague and friend, Margalit Ziv, and we showed that 3.5-year-olds are able to teach each other, mostly through demonstration. And 5-year-olds teach each other, often through explanation and contingent teaching, meaning I teach, the learner's knowledge changes, their emotional state, their motivational state change, and then I adjust my teaching to what it is that I think is happening emotionally, cognitively, etc., with the learner. But it turns out that teaching does not magically appear at age 3.5. Something else happens. It isn't that they don't have any of the background. And then poof, age 3.5, there it is. No, that's not the case. Next slide, please. So there's work by Professor Ulf Lieskovsky from the University of Hamburg. And what they found is that pre-verbal 1-year-olds, they understand a little language. They themselves don't speak. They can recognize a knowledge gap, and they act to reduce it. Those are prerequisites for knowledge transfer. Reducing the knowledge gap is transferring knowledge, but they can't speak. They're pre-verbal. So here's an example. Dr. Nandita is in her laboratory, and I come with my 1-year-old child who does not speak, and we sit down in her lab, and Dr. Nandita says to my child, my 1-year-old child, look at what's on this table in front of us. There's a cube, and there's a pen, and there's a shiny key, and she picks up each of them when she's talking about it. She takes the key, and Dr. Nandita puts the key on the edge of the table next to the child, 1-year-old, my 1-year-old. The key falls down. Dr. Nandita did that on purpose, and she pretends that she doesn't know that it fell down. And then she says to the 1-year-old, my child, there was a key here a minute ago. Where's the key? Well, the 1-year-old, my child, had seen it, where it is. And so She points to where it is. And you can say, okay, so who cares? I mean, I don't know. Dr. Nandita doesn't know where it is. You ask the child and the child points. Big deal. Not much is happening here, but think about this. The child thinks that Dr. Nandita does not know where it is. The child knows where it is. So there's a knowledge gap. And when the child points to where it is, the 1-year-old is reducing the knowledge gap. That's one of the prerequisites for teaching. And I think it's amazing. If you get goosebumps from the idea of what I just said, then you might find interest in work in these kinds of areas. Okay, so next one, please. Next slide. So what's the bottom line here? Teaching, because 1-year-olds have the basics, some of the basic components for teaching in place. 3-year-olds already know how to teach without having been taught how to teach. This is kind of evidence for teaching being a natural human ability. Okay, next slide, please. So here's the second line of evidence for teaching being natural. It's possible that there was teaching among our ancient ancestors. The place to go looking is what's called knapping, stone tools. Knapping is breaking off parts of a stone with another stone, creating a tool. And it turns out there's a 1.8 million history of the construction, the building, the knapping of stone tools. And the next slide, please. And you can see in the slide how sophisticated and how complex the stone tools became over time. This is called cumulative culture. You begin with an invention, you pass it on to others, and it maybe gets adopted in the society. And over time, 1.8 million years, a lot of time, you have more and more complexity and refinement in the kinds of tools that have been created. The next slide, please. So what's involved in this? There's innovation. There's transmission. Somebody has an idea. He transmits it to somebody else. And then there's learning. The next slide, please. Dr. Nandita. Okay, so there's innovation, transmission, and there's learning. The way that knowledge transfer is, knowledge is transmitted is through teaching. That's one mechanism. So even 1.8 million years ago, there's some evidence, there's discussion about this in the literature of cognitive archaeology, that teaching took place. And if it took place, that could be evidence for teaching being a natural human ability. And here's a guess. There were no schools 1.8 million years ago. There's even controversy, or at least questions, about whether there was even language among hominids 1.8 million years ago. Yet it appears that there might have been teaching taking place. Okay, next one, please. There's a 400,000-year-old cave in Israel, as I said, about a half an hour drive from where I live. And there are two researchers working in that cave more, Avi Gofer and Ella Asaf. And what they found was tools that were created, that were fashioned in the cave 400,000 years ago. And the tools were found in certain locations. They weren't found everywhere in the cave. And what they found also is that at the same location, there were some tools that were made by hominins with different skill levels. So there were experts and experienced and novices working on the same tool. It's possible. This is speculative. It's circumstantial. It's possible that the experts passed on information about how to nap with the experienced, and both of them with the novice. We have no way of knowing. Teaching is not like a bone or a tooth where it stays for 400,000 years ago. So we can only speculate as to how is it that, or what happens when the same tool has been worked on by individuals at different levels of skills. And the claim is, among some, that it's very possible that teaching took place in those situations 400,000 years ago. Okay, next slide, and this will be almost the end. Is teaching universal? There are some people, who I said earlier, who think that it's possible that it is not universal, that there are some hunter-gathering societies without teaching. In our existence as human beings, 250,000 years ago, we've been around as Homo sapiens sapiens. Anywhere between 75 and 90% of our existence was as hunter-gatherers. What could we find teaching in modern hunter-gatherers where there are no schools among them? Next slide, please. There's in the Congo Basin, there's a group called the Aka, AKA. They're a band, they're called them. Small groups are called bands. And they are pygmies. And the picture on the bottom right is a man of regular stature with the pygmy Akas. And work was done by Barry Hewlett, among others, looking to see whether or not teaching occurred. Teaching occurs in the Aka bands. Get the next, please. And the next also. So, so there's some, the next one, please. There's some controversy about teaching in hunter-gatherer bands. I believe there is adequate evidence for teaching, but because we're in an academic environment and institution, I suggested you not believe me, right? Don't trust what I say. See what the evidence is for those who say there is teaching and for those who say there is not teaching among hunter-gatherers, and then you decide for yourself. I won't go into all the reasons why I believe that there's adequate evidence for teaching. And here's one of the points. There are no schools in the Aka hunter-gatherer tribe band, yet there's teaching. A mother teaches a child how to break a nut, crack a nut, so that he can eat the meat inside of the nut. And she shows where there's a fault line, and that's the place where you hit it. And she shows him that, and she demonstrates, and she monitors what he's doing. And she says no when he's doing it wrong. And she smiles when he's doing it right. These are kinds of evidence that teaching is taking place. It's really complex, but it's terrific, I must say. Okay, next slide. So there's a bottom line here, which is about my claim, which is that teaching may just be a natural ability for humans. I presented three kinds of evidence for that. One is that children teach even though they were not taught. 1-year-olds teach, and they don't have language yet. They have the basics of it. Our ancient ancestors from 1.8 million years and 400,000 years seem to have taught, but again, it's circumstantial evidence. And teaching may very well be universal. Among humans, all of these together indicate that it might be a natural ability. Very last thing, when we teach, there are aspects that are there between the interpersonal part. Have the next slide, please. So that in teaching, it requires good teaching, requires empathy and sensitivity. You move from a relationship of inequality, somebody knows, somebody doesn't know. And teachers do not abuse that power. There's a willingness to share knowledge, no small thing. There's a willingness to accept the knowledge of somebody else. That's implicated in teaching, even though it's not teaching itself. There's also responsibility for and a commitment to others when you teach. This is part of the interpersonal aspect of teaching. When it is done well, teaching is a profound act of respect and friendship. Anybody who's had a good teacher and anybody who feels that something special happened, almost magical happened. Nandita, could you press the next one? When it happens, you know that something magical happened between you and a teacher, or you as a teacher and a pupil. There's a deep, deep forming of friendship based on respect. And the last one is there is a kind of a spiritual communion with others when teaching goes well. These are aspects of teaching which are rarely looked at in the scientific world and not written about very much in the academic world. And the last slide, thank you very much for your patience. Of course, I couldn't see if you're patient or not. And hopefully your interest, well, I hope there was interest, but who knows? As I taught, that's what I was doing now. And if you think about what I was doing in the teaching, and you think about what I talked about too long, much too long, you will see that you might not have even thought about what I'm doing is teaching, because it is so common. It is so ubiquitous. And that's what I did. And if you look back now on what I talked about, you might see something extraordinary happening. Not that I'm an extraordinary teacher, but what happened in the teaching is extraordinary. So thank you very much. I apologize for talking too long. And thank you again for the invitation, Dr. Nandita.
Thank you so much, Dr. Sid. One thing I have to disagree, though, you're an excellent teacher, and we experienced that over the last years, really, not only few, but I think the entire team. So thank you really for your insights. And so
Thank
now,
you.
in a nutshell, human teaching is a natural ability, which is actually part of your hypothesis and your research focus over the last decades. I know that other researchers get inspired by this insight. For example, students in Germany, as we had once a conversation that your paper actually inspired students to rethink. So it is remarkably complex. 1,000 days old children can teach and have the ability to recognize a knowledge gap. So it is a knowledge transmission. And what I found especially interesting is that the example of being a mother teaching the child, being able to smile to the child, give nonverbal feedback, verbal feedback, and all the other aspects which are there of teaching with a mother to the child. So in other words, it's pro-social. So now we see how rich human teaching is actually. And with the new technology now, we are very eager to translate these human qualities into machines, into algorithms, and into our learning systems of different learning technologies. So allow me to use this as a bridge, and let us stay in conversation, Dr. Sid. Allow me to introduce or invite Dr. Kamal at this point, perhaps with the first question that Dr. Sid, I invite you as well to ask Dr. Kamal questions. I was very wondering, and please participants join me if you feel the same. Dr. Kamal, now we heard so interesting aspects of human teaching. Where do you see actually the future of teaching in the context of artificial intelligence? Would you have, would you kindly share your rich knowledge or your insights with us? And you're muted, Dr. Kamal.
Thank you, Dr. Nandita. So yeah, I think you know, the emotional and the human element that Dr. Sidney, you know, brought out, and you know, and earlier, you know, he has shared with us his work on you know, peer-to-peer learning, you know, how children learn from each other, and that emotional. We find that emotional thing also practically in the classroom, you know, we are using peer-to-peer learning and grading now, you know, inspired by Dr. Sidney's, you know, guidance, you know, a few years back. And so we, you know, because, you know, the students are very comfortable with each other. But when a teacher comes, you know, they're like in a different, you know, the energy level of the whole classroom can change, right? So, you know, that aspect of human and emotional intelligence, I still feel is the underlying, you know, if the human is emotionally relaxed, calm, and love is there, then the person is open to learning, you know, and that part I think is fundamentally very strong. You know, that is the most important thing. If somebody is tense, right, or angry, or, you know, tense or stressed or whatever, you know, the learning really cannot take place in a loving way. So the whatever Dr. Sidney said and what we have been learning from him over the years, I think is remarkable, because that is the foundation of learning, right? So I think that remains there. You know, what we are bringing to the table in terms of what we teach, the subject matter, right? That's the content. So we bring some content for teaching. And then now, you know, what you're asking me today is how do we see teaching in the context of artificial intelligence or AI, or, you know, or I will give some examples using maybe ChatGPT, because that happens to be the most popular tool that we have nowadays, that most people are, somewhat familiar with, right? So I will list, I think, role of AI in teaching and learning. I will combine that. I will list around 4 to 5 points, which I will say will help teachers and students. And there are a few points which about ethics, privacy, cheating, copying, and so on, which also have come up because of a tool of ChatGPT, and those are serious concerns, actually. So AI can be a double-edged sword, and so we have to have proper. We have to use the advantages of AI, but temper it with proper, policy, usage, and in the context of applying it in our environment, right? Okay, so let me list a few points. I think the first point that we are working on ourselves is personalized learning, right? So every student, AI, as a human teacher, I don't have time personally for each student, right? So AI can be built in a way that every student's, strengths and weaknesses are measured semi-automatically or automatically by the system. And then, AI prescribes to them in which topics they are weak or strong. And so they can focus on their weaknesses, and where they are strong, they can become even stronger or go into research and innovation, for example. So that is about, personalized learning can be a big foundation for us. Based on that, we can have intelligent tutoring systems. And actually at Amrita, we are building one, and I will talk about that later. So an intelligent tutor would, basically offer one-on-one tutoring that mimics human interaction, right? So it would do that, based on technology. And that would be scalable across many students, right? So that if I am weak on something, it will help me with that area. And if I am strong in something, it will motivate me to go even higher or deeper in that subject. The other part of AI, and I'm not sure if that, see, the software technology, has been with us for many, many years. And what is AI is also a part of software technology. So I think there's a lot of hype around the word AI, which is fine. But we should finally understand that, so-called AI, is basically giving us a natural language interface to information that exists in some databases behind there. So just keep that in mind. It's not some wonder or some magic that's happening finally. It is information retrieval systems that are now, interacting with us in which were not possible before. So we should, have realistic expectations and have good policies in place, right, for that. Now, for teachers in administrative tasks, AI can help a lot, of course, in grading, in attendance, and other administrative tasks, it can help a lot. Even I have seen, even ChatGPT, if I tell ChatGPT, give me a question and grade my verb, not just multiple choice, even if I write a Python program code-wise, it will tell me where I went wrong in that piece of code. If I write an answer as a social scientist or as a cognitive scientist, a paragraph, then it will tell me whether it is up to the mark, whether I'm covering all the points. So it can really, it's not perfect, by the way, and that therein lies the danger of ChatGPT, right? Because it is not perfect, we always will need, real teachers. And so that administrating task automation can be a big boon. I think enhanced content creation is another area where AI can help us. If I have my notes, for example, it can help me to get images. With those images and text, I can create better PowerPoints, videos, maybe more compelling content, you know. That area, AI is still on the borderline, I would say. It's not fully there, but you can create DALL-E images and some videos and some PowerPoints, but they're not great. But it's getting there. All those areas, Google and Microsoft and Meta, they are all in a war, right? I mean, trying to develop the latest AI technologies. Then the next thing that AI will really help us, I think, is in data-driven insights. So that, if I was, poor at math in my 5th grade, and then, I'm still, depending on, I may still be poor in certain portions of mathematics, but I may be good at some. So the AI, maybe if AI has access to all my questions and answers, then it should be able to figure out that, oh, he never really learned calculus well originally. And so now, he cannot solve problems that depend upon, differentiation and integration, for example, right? So if I did not learn certain subject earlier, the AI may be able to figure out deeply. And then based on a lot of data across many students, it will give me patterns and insights. And I can even build, data-based models. So these, 5 points, I think, personalized learning, tutoring, administrative tasks, content creation, and data-driven insights are the plus points. The areas where AI will bring challenges, I think, is, that we already find in our, Amrita, day to day. You give the students a question, they will, just use ChatGPT, put the answer there. And now, how do you grade them? How really do you grade them? I mean, there are systems where you can feed in all these answers and find out that they are taken from ChatGPT. But, then there are programs which will take the output of ChatGPT and make it non-ChatGPT. So, this is an endless game of, thief and police, right? You steal and you get caught, and how well to, cheat. But, the question finally is using ChatGPT cheating or not? I mean, that is a policy decision that we need to make in our context. And for now, at least in AI, we are teaching AI. So we just say, use ChatGPT, all you can. But we do not evaluate them on, those kind of question and answers anymore. We evaluate, most of our evaluation has changed to project-based learning. So I think, instead of evaluating them on what they memorized and what they can do, but this is definitely a gray area, that needs to be thought about. How do I, deal with this, as a teacher, as an instructor, as an evaluator? I know my kids are just plugging in the answer, getting an instant answer, and they're doing nothing probably, some of them. So how do you deal with it? The other is, the AI can bring in a lot of, malicious things, which I don't want to go into detail, but, we need to understand that to use AI, we need to be ethical, and being ethical is a very important area, but it's a whole another subject. So I would like to leave it at this as my answer, that, how to evaluate is going to be a challenge for teachers when AI is used by students. Thank you. Thank you very much.
Thank you, Dr. Kamal. Indeed. And thank you for the 5 areas you have mentioned and possible way out of the challenge through project-based learning, which is actually quite welcomed by students. Hands-on learning, learning experiences, which are hands-on. Allow me one more, maybe short, a question with a short answer. Where do you see the role of cognitive sciences in the context of AI or intelligent tutoring systems?
Role of cognitive sciences, can be in several ways. I think cognitive sciences provides insights into how humans think, learn, and process information. And so that aspect is very important for the designers of AI, right? because, if I'm building a tutoring system, for my students, then I need to think about how will my student use this information? How will the cognition take place of that subject matter that I'm trying to teach them, for example, right? So that whole aspect. So I think for AI designers, some courses or some knowledge of, cognitive sciences and maybe psychology is very important, right? Because they need to understand, they need to put themselves in the shoes of the learner, as a teacher. And for that, learning cognitive sciences is very important. And the second area I would think is that when we are building AI systems, we have to think about human AI interactions. I'm building a system which will respond. I'm building menu-based, I'm building dashboards, I'm building so many user interfaces. For all of those, the knowledge from cognitive sciences helps design AI systems that interact more naturally and effectively with humans. Okay, so that is also very important. And finally, I would say that, AI systems like ChatGPT may give you right answers, but they are poor at explaining anything they do. Okay, so explainability is a weakness of current AI systems, for example. But with cognitive sciences, we can develop AI systems that can explain themselves also. So I think those are the 3 points I would like to suggest for now, that, basically cognitive sciences is very important for AI scientists to understand and learn, how to design systems, then the human AI interaction and the explainability.
Wonderful. Thank you, Dr. Kamal. Indeed, in our master's program of Cognitive Sciences, Learning and Technology, we blend these disciplines to really design meaningful learning experiences and teaching environments for generations to come, because we are on the crossroads now. Allow me now, please, dear participants, to invite Dr. Unni to the podium and deepen a little bit our conversation. Unni, I know that you have worked so many years on educational technology, learning technology, and human-computer interaction. So I would like to start with a question which dives a little bit deeper on the basis of what Dr. Kamal ji just shared. So do you think, Unni, that there are applications of learning and the cognitive sciences which goes beyond building smart learning systems?
I'm sorry, can you just repeat that?
I was wondering, do you think there are applications of learning and the cognitive sciences which goes beyond building smart learning systems?
Yeah. So, I mean, just for the sake of the participants, I'll try to continue from what Dr. Kamal was saying. I think I was fascinated by both Sid's presentation and Dr. Kamal's wonderful response to the earlier question. So let me just start with the aspect of cognitive sciences that can inform AI and the design of smart learning systems. So I just address one part of smart learning systems that we all know about, that Kamalji also mentioned. It's these large language models, for example, ChatGPT. So what is happening right now is the kind of approach that a lot of these cutting edge research labs on AI and all these university labs that are working in this field, what they're looking at is they're trying to apply, all these theories of cognitive sciences on understanding how these LLMs and how these ChatGPT-like models work. So what we have right now is, we have trained these big models that, with terabytes, petabytes of data from the internet, textbooks, books, people's, chatter on social media. So it has learned a lot. Okay, so it has modeled how humans, communicate with each other. And so we have built up this big black box kind of thing that's very hard to understand. It hallucinates a lot. So if you have used these models, you'll see that, okay, sometimes it just makes up stuff, you know. So you ask a question and it's super confident because it has learned how humans respond to, you know, questions. And so even though it may not know the right answer, it'll just pretend as if it knows the right answer. So people want to understand, you know, like one thing that Kamalji was mentioning was explainability. So how do you understand what these things learn? And there are a lot of techniques being used. For example, there are aspects of cognitive science that align with neuroscience. So you're trying to understand, okay, if you ask a particular question, let's say about, you know, let's say, I'll give you an example that recently just happened, like last month. So there's this company called Anthropic, which made this model, which makes this model called Cloud, CLAUDE. So they came out with this, you know, explainability paper where they try to understand, you know, if you ask a question, which parts of the neurons, okay, which parts of the internal architecture gets activated. So they found that, okay, if you ask a question on, you know, the Golden Gate Bridge in San Francisco, a certain part of the model gets activated. So, and then what they did was they tried to increase the strength of that part of the network. And what happened was the model started pretending as if it was the bridge. So it assumed the role of the bridge. And it's like, okay, I am a big, beautiful bridge. You know, I have strong foundations, deeping rest in the water. So it's very weird if you really think about it. So it's not a, you know, it's not exactly a human, but yeah, if you start taking approaches from cognitive sciences, you know, all the learning sciences, psychology, all these things, and you start applying it to these large language models, you will start getting, you know, really cutting edge insights, which is required to create, you know, better models, ChatGPT and all those things. So it's not just learning; it's also, you know, like the actual creation of these AI systems is also informed by, you know, approaches from the cognitive sciences. And then I would say, so you know, like another example is, so in cognitive sciences there are a lot of examples of cognitive biases. So I mean, you know, a human will have a lot of you know, lots of biases. If you just just go to Wikipedia, search for list of cognitive biases, you can see there are like tons of fallacies and, you know, wrong ways of thinking that humans are very used to. All of us are subject to it. So what they found was that there are some papers that came out. So these large language models are also subject to these kind of cognitive biases. So you can actually like use prompts. You can just ask it certain questions and see that, okay, this thing is biased in some ways. So one example would be, you know, like if you ask a question, like if you give it a picture, if you give pictures of, or you ask the model to generate a picture of a nurse. So usually it generates an image of a female nurse. Or if you ask it to generate an image of a doctor, it generates some, you know, an image of a male doctor. So there are inherent biases inside these models, and you need to find out, you know, like by like taking approaches from cognitive sciences, you can actually you know, like dig in to these models, ask it questions, and find out its biases. So then you can, you know, kind of build these kind of guardrails around it. You can retrain with, you know, certain reinforcement learning you know, techniques, which is also like, you know, inspired by how humans learn. So yeah, so I think there are a lot of techniques that goes beyond, you know, the design of smart learning systems.
Yeah, thank you, Dr. Oni. That is really very insightful, and we could see that the potential of cognitive sciences is not a nice to have. Actually, it's a necessity to build future learning systems, tutoring systems, intelligent systems, and beyond. So maybe a very short answer to two questions, very short. So how can, for example, and we offer that in our lab, we collaborate very strongly with labs and other departments at Amrita University, and we are going to use equipment such as virtual reality, augmented reality, haptics. Just a short answer, Dr. Uni, where do you see can virtual and augmented reality enhance learning, because we will expose our students to these technologies?
Yeah, I think so your question is, how can cognitive sciences inform?
Yes,
Yeah,
yes,
yeah.
yes.
So 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 like so my PhD was in this area. So I was trying to go deep into understanding what makes VR training work. Now this is an area just like AI, there's a lot of hype around VR and AR learning. A lot of companies have come out with products that, like, that sometimes work, sometimes don't work, depending on the approach. So the right way to make these systems is to consider all these learning theories. You need to understand how people learn and what are effective teaching strategies. So that is for sure. And there is one, there are some existing or like cutting edge work being done in this area. Uh, so actually, the leading model that explains, the design of effective VR learning or teaching systems is called the cognitive. Let me just see what the name is. So it's called the cognitive multimodal immersive learning theory. So it's called CAML, CAMIL. So what it does is it uses aspects from cognitive sciences, from psychology, trying to see, how does the motivation, I mean, just like Sid mentioned, what is the emotional state of the person? Are they motivated? Are they, are they stressed out? So all these aspects is there. So how do you combine that with the benefits of VR and AR, which is immersion? So you feel as if you are, inside a different world or a different environment. So how do you essentially bring these things together? So it's not as like there are certain solutions which take, like let's say a video which could have been shown on a screen and just put it inside a VR headset, which is completely unnecessary. Like why would you just put a video inside a VR headset and expect that, that to be better than just simply watching the video? So if somebody's curious, just search for Camel and you'll find that cognitive sciences is actually the foundation of the design of effective VR learning systems. And another thing that I worked on was the design of the understanding stress. How stressed someone is while they're getting trained in a VR environment. And what I've seen is we have sensors right now. So we have like this heart rate monitors, these kind of brain sensors and pupil dilation, a lot of things from the body itself that you can measure to understand how how stressed someone is. But it still has a lot of limitations. For example, if you just get raw signals from the human body, you can see, actually you can see on like if you plot it, you can see, okay, at a certain point when some kind of feedback is given, some kind of extra information is given, you can see that, okay, there's a jump. So it means that they've become more activated. They've become more interested or stressed, but you don't know if it is stress or if it is simply that they're excited. So you don't get the context. So for context, you need more information. You need to see the facial expressions. You need to also consider the cultural context. So for example, the way someone learns in Japan and the way someone expresses their emotions in Japan will be different from the way they express in the United States or India. So you need to understand. So you need to consider a lot of data. So it's you have these multimodal approaches to understanding a complete picture of of the learner. And I think that is the future.
Thank you so much. So we are coming slowly to the end of this webinar, but before we end, I would like to read out our questions from our participants, and I'm inviting our experts to answer those. So one question is, what is cognitive empathy question mark, and how does it play an important role in teaching, and how can we effectively use this in learning and teaching? Perhaps Dr. Sid, this is a question for you. If you would have a short answer. We have another one before I hand over to you, Dr. Sid. And stay tuned because Dr. Uni will perhaps share a few words about on tips on how AI can accelerate students' learning and how it can prepare them for the future. So, but now let us get a short answer on the first question of one of our panel members. Dr. Sid, what is cognitive empathy in your perspective? You're muted, Dr. Sid. Very shortly so that we can move on to the second question.
No, okay. No, I understand why you're saying that. There are different kinds of empathies. So rather than giving a specific answer to what is cognitive empathy, let me, Jewish people, when they're asked the question, they usually answer by asking a question. So I'll ask a question to the person who asked the question. Do you think that when you're teaching, you are looking at the person who you're teaching? If it's a tutoring one-on-one situation, you're monitoring what's happening. You're monitoring what you believe is their emotional system, or how they're responding emotionally, motivationally, what they understand, what they don't understand. And there's some people who are more attuned than others about that. I think that teaching can actually foster empathy and can foster compassion to big ideas that are central to Amma's work and to work being done in Amrita. What I'm not sure about, for sure, is can something like that actually happen between ChatGPT or any other large language model and people? Between people, it works sometimes, it doesn't work sometimes, but you have a sense of how it's going. If it's going, is there anything that can be done in the artificial intelligence that can bring about trust between the intelligent tutoring system and the person who is who's being taught? Last thing, you might want to reverse it. Maybe you want people to teach computers, and then they can become more empathetic, let's say, to these tutoring systems, and teach the tutoring systems how to become empathetic towards others. But okay, thank you.
Thank you, Dr. Sid. So I shared a question for Dr. Unni, and I think Dr. Unni responded. So I would take one more question and then we end our session today. And at the same time, I'm also sharing the screen, showing job perspectives and future prospects of a student who graduates with a master's in cognitive sciences, learning and technology. Coming back to the question of our participant, I want to work on a project, a physical toy interaction with an AI by storytelling, taking reference from Indian mythologies like Ramayana, Mahabharata, or other books, not only Indian mythologies. Dr. Kamal, may I invite you to give your feedback or your thoughts on this idea or interest of one of our participants?
Sorry, I didn't quite maybe hear it properly or understand it properly. Can you please repeat the question?
Certainly. One participant is stating here that he or she wants to work on a project which could be called a physical toy or a physical toy interaction with AI by storytelling, taking reference from Indian mythologies such as Ramayana or Mahabharata or other books from the Indian scriptures. So any reaction to this idea, or perhaps
Sure, absolutely. You know, I think that's a fantastic idea. You know, we actually, are already we are building like a, building a 2D game right now to teach kids about loving nature, and therefore And we the main elements of that game that I'm doing right now with a team of people is about learning about, water, trees, and energy. So those are the three main areas that, in this game. But in the game, everything is alive. Every character is alive. The water is alive. The trees are alive. The solar panels are alive. They talk to the kids, So it's a very animated kind of a Disney kind of a feeling that we try to give to the kids so that, they get engaged interactively. So it's not, see, when you watch a Disney cartoon, it's one way, right? But, when you are in interactive game, you have to act, right? You have to do something. So it is interactive. So you always, when you play something, you're learning and, you're interacting. So similarly, your idea of having, any toy, any robot, which has the inbuilt knowledge of, Ramayana. I mean, you could do it in, I think, several different ways. You could take the ideas or the teachings of the Ramayana or Mahabharata or whatever, and bring those to the fore through some magical characters. Like, or you could bring some character, let's say like Hanuman, from there, like this big, monkey god. And then, that would be fascinating for kids. And then I, as the kid, if I'm talking to Hanuman directly, and behind Hanuman, you could put, all the teachings of Rama and Hanuman from the Ramayana. So when I talk to Hanuman or ask questions, actually the Hanuman character in the game or the robot or whatever box you design is actually, going back to the knowledge system of which has been taken from Ramayana, and which is of Hanuman and all. So I think you'll have to do several things here. You'll have to go to the original, some simple Ramayana, get all the teachings of Hanuman and Rama, collect them all, and that becomes the knowledge base of the Hanuman character, for example. And then, when I interact with a system, this is very common in AI right now, and it is called RAG systems, okay? Retrieval Augmented Generative, right? So in this case, the AI system, the natural language processing happens only on that specific body of knowledge. So what I mean is ChatGPT, gives you answers from anything about anything, right? But here you can take an open source LLM like Llama, let's say, for example, or Mistral. You can take something like Llama and build a model which will have the documents and knowledge, for a character like Hanuman from Ramayana. And then when I ask it questions, the system will talk back to me as if I am, interacting myself with Hanuman in the forest, maybe. And the background text can easily nowadays be converted. There are good APIs for, voice to text and text to voice. So that can all be very nicely integrated. I think it's a great idea. It's a super good idea, and I think you should do it.
Wonderful. Thank you. Thank you, Dr. Kamal. At the same time, I also scroll to our webpage of the master's program so that students can see that their interests are aligned with our curriculum, and especially with our expertise, which we have, for example, at the School of Artificial Intelligence. And Dr. Kamal is also releasing master programs launching in this August. It is worth to visit our web pages. Now we came to the end of our webinar, questions dropping in more and more. So we could talk much longer and much more in depth, but we will offer a series of webinars under our department. So you can rejoin and we can continue our conversations next week, the week after. So the entire June is reserved for offering webinars for interested participants, parents, potential students, and colleagues. Then let me officially thank all our experts, our panel members, Dr. Sid, Dr. Kamal, Kamalji, and Unni, that you enriched our webinar today with your insights, with your knowledge, with your expertise, with your answers to the questions of the participants, and your unique out-of-the-box perspective. So, dear participants, indeed, we have here a cream de la cream of researchers who moved a lot in their field and have still the energy to dive deeper and to transform, all in the service of or in the context of social good. Thank you so much for joining. It was indeed an honor. I learned a lot. And I'm thanking also all the participants. And I hope we will see each other again next week. Have a wonderful weekend and a wonderful week ahead. Namaste. Om Amriteshwari Namaha.
And thank you very much for everything, including being an absolutely wonderful moderator. Thank you.
Thank you so much.
Thank you. Thank you. Thank you. Thank you, Dr. Nandita. Thank you.
Thank you, everyone.
Thank you.